Hello students, this is your professor, Dr. Mink, and this lecture is 98.3%, more like 98.9% review. Sorry, couldn't help myself. The conditionals and loops, the flow of control commands, have almost the same syntax in Java as they did in the language that we studied in the prerequisite course. So I'm going to blow through these lectures, and you probably can too if you paid attention in the prerequisite course 121. Let's take a close look. No surprises here. Chapter scope includes flow of control. We'll move from linear to iterative and branches. Cover Boolean expressions, if and switch statements, comparing data, while, do, and for loops, and also iterators. As we learned in the prerequisite course, statement execution by default is linear unless we change it with either a branch or a loop or some other nonlinear flow of control. And the decision whether to loop or branch is always based on a Boolean expression or expressions that evaluate the true or false. And the order of statement execution is called, as we've mentioned, flow of control. Conditional statements let the program choose which statement or statements will be executed next, sometimes called selection statements. They give the program the power to make basic decisions, if then else type statements. The Java conditional statements are the if statement, the if else statement, and the switch statement. It's total review, but if is a Java keyword, reserved keyword. The condition must be a Boolean expression, and if the condition is true, the statement, in this case the single statement, is executed. If it's false, the statement is skipped. Generic or basic if statement. Relational operators in Java are the same as the relational operators used in C++, as featured in the prerequisite course for this. So we have equivalence, not equal to, less than or equal to, greater than or equal to. Once again, the only difference here between Java and C++ is how we send the string message to the output stream. The if statement is structured exactly the same, and so is the Boolean. Conditions can also use logical operations, such as the logical not, logical and logical or. Not is unary, the other two are binary. This is total review from the prerequisite course. Logical not, also called logical complement or logical negation. It flips a true to false and a false to true. No surprise here. And or work exactly the same as they did in the prerequisite course, so we don't need to spend a lot of time talking about that. Some truth tables as covered in the prerequisite course, showing A and B, A or B. We can use logical operators to form fairly complex conditions, Boolean conditions. You should know all logical operators have lower precedence than the relational operators, and not has a higher precedence than and or. And as always, we use truth tables to evaluate, or can use truth tables to evaluate specific expressions that use logical operators. And here's a typical example. In Java, just like in C++, we have short circuit operators, logical and logical or are short circuited without the presence of parentheses. They'll be evaluated left to right, and if the left operand is sufficient to determine the result operand is not evaluated. Please notice the if statement works exactly the same as it did in C++. In this example, the print statement is executed regardless of whether or not sum greater than max is evaluated as true, because there is no body, there is no scope. It's a single statement is the body of that if statement. This diagram shows the flow of the if statement. If the condition evaluated is true, then the statement following the if will be executed. If not, it'll be skipped. Here's a simple program. I'm not going to load this into the IDE and compile and run it, but it has a simple if statement. If age is less than minor, and then it prints youth is a wonderful thing and joy. If not, it prints age is a state of mind. So there's a single statement that will be executed if the condition in the if statement is evaluated as true. The only differences here between the prerequisite language studied in the prerequisite course is we use the scanner class to create a new scanner object and pass system.in in the constructor, and instead of cin, and we use system.out.print instead of cout. Everything else is pretty much the same. You'll notice that the statement controlled by the if statement is indented to indicate its relationship with the if and Boolean. This is not a requirement. It is a stylistic endeavor. However, the use of consistent indentation makes a program much easier to read and understand. You don't have to indent the statement, but it helps. The if-else statement is exactly the same as it was in C++, the language covered in the prerequisite course. Here you have a Boolean condition, and if it's true, statement 1 is executed, and then we skip past statement 2. If it is false, we skip statement 1 and execute the statement 2, which follows the else statement. If you took the prerequisite course, CSC121 with me, and I teach about half of those sections, you'll remember in class we did a payroll program where we implemented an if-else statement to determine the gross pay of an individual based upon the number of hours they worked. And the condition was, or the boundary condition was 40 hours. If someone works 40 hours or less, they get paid straight time. And if they work over 40 hours, they get paid time and a half. Here's a program that does exactly that. It's actually 2 pages in these slides. So you'll see the Boolean expression and the if-else statement on the next slide. But simply we're setting this up so the user enters a number of hours worked, and then int hours holds the number of hours worked. And here you see the Boolean condition hours greater than standard. Standard was a constant declared with the final keyword. One slight difference between C++ and Java. Java uses final, C++ uses const. So if the number of hours entered by the user is greater than 40, we go into overtime pay, else pay is simply the hours times the rate. You'll see, if you remember all of the formatting flags we had to pass to the cout object. They're all handled differently. So here we declare number format FMT equals number format dot get currency instance, and then we just simply call FMT calls format, and the argument is pay, and it will return the pay, which is a floating point variable. We'll return that in the currency format when we print it. I strongly urge you to take this file, put it into a Java project and run it if you're sketchy on any of this. Up until now, the if and if else executed a single statement. Wherever we have a statement, we can put a block of statements. Follows the same exact syntax and structure as in C++. You just simply put the braces, and then that becomes the body of the true or false. This slide depicts the syntax of the if-else statement with a single statement executed if the condition is true, and a block of statements executed if the condition is false. Another small program that demonstrates the use of a multi-statement block. This program uses a random number generator object to generate a random number between 1 and 10, and then ask the user to guess it, and we'll take a look at the if-else statement on the next page. So if guess is equivalent to answer, you print you got it, good guessing. Else, you print that's not correct, sorry. And else has a block of 2 statements. You also print the number was plus answer. This is a review, but it's an example of where I'm assuming the programmer intended for the true statement to be 2 statements, and indenting 2 statements after an if statement does not make that a block. Okay, it's only going to execute the system out.println statement if that's true. And error count ++ will be executed every single time regardless of whether or not the Boolean is evaluated as true. This should be obvious, but if it's not, take a close look at this. In an if-else statement, both the if and the else portion could be block statements, obviously. And it's not mutually exclusive. One could be a single statement, one could be a block. They could both be blocks, they could both be single statements. Java also has a conditional operator that uses a Boolean condition to determine which of 2 expressions is evaluated. Here's the syntax. We'll take a look at an example in the next slide. Here's a coded example of the conditional operator. Larger equals num1 greater than num2. So if num1 is greater than num2, then num1 is assigned to larger, otherwise num2 is assigned to larger. It's considered a ternary operator because it requires 3 operands. Here's another example of the conditional operator embedded in a system out.println statement. So if count is equivalent to 1, then dime is printed along with the string literal. Otherwise, dimes is printed. Nested if statements work exactly the same as they did in C++, which was covered extensively in the prerequisite course. A statement executed as a result of an if statement or an else clause can be another if statement nested. Obviously, you're going to use braces and you'll have various blocks, but it's the same. Here's a short program that demonstrates nested if statements in Java. We solicit the value of 3 variables from the user, num1, num2, and num3. Then on the next page, you'll see how a nested if is used. Nested ifs are used to calculate the minimum of those 3 values entered. So no big surprises here. So if num1 is less than num2, so if that's true, we drop down into another if statement. And if num1 is less than num3, then min is assigned num1. Now that else is connected to the inner if. And indentation does play a useful part in this, although it doesn't necessarily impact the flow of control. I would have preferred some braces for blocks for the inner nested branches. Take a close look at this. If you're feeling uneasy about any of this, obviously you need to download this program into NetBeans, run it, and refamiliarize yourself with nested if logic. When you're comparing data using Boolean expressions, it's important that we understand the nuances, aka differences, between certain types of data. So, comparing floating point values for equality is pretty straightforward. However, comparing characters or comparing strings or comparing objects versus object references, it gets a little bit different, a little bit more complex than the primitive data types. It's probably a good idea to rarely use the equality or equivalence operator when comparing 2 floating point values, floats or doubles, because they're equal only if their underlying binary representation matches exactly. Now, if you've already taken CSC122, you'll know that floating point and double numbers are represented with floating point equivalencies in binary, and slight differences in values will make those 2 numbers not equivalent. So it's advisable to avoid using equivalence in floating point numbers, because comparing a decimal number versus its binary equivalent is it's sketchy, because we're talking about a base 2 system versus a base 10 system, and so any number that's not a power of divisible by a power of 2 in a decimal system needs to be converted or approximated in a binary representation to be stored by a computer. So here's one way of doing this. To determine the equality of 2 floats, you may want to use the following technique. So we're going to have a tolerance, and if we subtract the 2 and the absolute value of the difference is less than the tolerance, they may be considered essentially equal. As discussed earlier, Java character data is based on the Unicode character set, which establishes a particular numeric value for each character. So therefore, the characters do have a numerical order, and we can use relational operators on characters based on the Unicode ordering system. So the character plus is less than the character J because it comes before it in the Unicode character set. If you look in your book, Appendix C provides an overview of Unicode character set. As would be expected in Unicode, the characters representing the digits 0 through 9 are contiguous and in order, and likewise the uppercase letters A through Z and lowercase letters A through Z are contiguous and in order. And there you have the Unicode values of those particular characters. In Java, a character string is stored as an object, so therefore we have the string class and we have methods associated with that. Those objects, and one is called equals. The equals method can be called to compare two strings, and it returns a Boolean true if they are exactly the same characters in the same order. And here's an example. You cannot use relational operators to compare string objects in Java. The string class contains a method, compare to determine if one string comes before another, and they're compared character by character until one is considered greater than or less than. The compare to obviously returns a Boolean. The compare to method in the string class uses a comparison called lexicographic ordering. I always struggle with that term. Lexicographic ordering takes a string, one character at a time, kind of decomposing it, and compares it to the same character at the same index in another string until they're considered equivalent, less than, or greater than. Lexicographic ordering is not just comparing letters to letters. Remember, a string can include any of the characters on the keyboard or the Unicode character set, so it can be a combination of lowercase, uppercase, any character you can generate with the keyboard, including numeric values stored as characters inside a string. So, for example, the string great, capital G-R-E-A-T, comes before the string fantastic because all the uppercase letters come before all the lowercase letters. Also, shorter strings come before longer strings with the same prefix. And the example given here is book, lowercase B-O-O-K, comes before bookcase. The equality, or as it's called in C++, the equivalence operator, two equal signs, can be applied to objects. It returns true if the two references are aliases of each other. In other words, the object reference variables are aliases of the same object. The equals method is defined for all objects, and unless we redefine it when we write a class, it has the same semantics as the equality or equivalence operator. It's been redefined in the string class to compare the characters in the two strings in lexicographic order, which is what we just discussed. So you can and should redefine the equals method to return true under whatever conditions are appropriate for the program you're solving. Java includes a switch statement, which is exactly the same syntax as the switch statement in C++ covered in the prerequisite course. Evaluates a single expression and then attempts to match the result to one of several possible cases. We'll take a look at the syntax next. Here's the general syntax of the switch statement. Based on the expression, it matches it to a specific case and then executes the statement list for that case. Next, we'll talk about use of the break. You must use a break statement and at the end of each case's statement list in order to transfer control to the end of the switch statement. If you don't have a break statement, the flow of control will continue into the next case. This may be appropriate, but it's often not the way programmers want a switch statement to work. Here's an example of a switch statement with breaks at the end of each case. pretty straightforward and the same as it was in C++. As in C++, a switch statement can have an optional default. The default case has no value associated with it, but simply uses the reserve word default. And if no other cases are matched, control gets transferred to the default statement. As in C++, the expression of a switch statement must result in an integral type, meaning an integer, a byte, short, int, or long, or a char. It cannot be a Boolean value or a floating point value. The next two slides implement a switch statement. The switch statement is based upon the value of category, which you should note is an int. Here we see the variable category used as a switch statement. If category equals 10, we'll go to case 10, 9, 8, 7, 6, etc. And if it's not 10, 9, 8, 7, or 6, it will execute the default. The content on loop should be 100% review. They provide the repetitive structure in programs, and we're going to cover, I should say, Java has three kinds of loops: the while, the do, and the for. The while loop is exactly the same syntax as it was in C++. If the condition is true, the statement is executed, and then the condition is evaluated again, and it will continue to execute the statement as long as the condition is true. This diagram shows the flow of control for the while loop. Here's a sample while loop. If the condition of the while loop is false the first time it's evaluated, the statement or block of statements is never executed. This is the same as it was in the prerequisite course. We'll take a quick look at some examples of loop processing. One of the most common applications for a loop is in maintaining running sum. Sentinel value, which should not be a new term to you, is a special input value that represents the end of input. Here's a small program that solicits a value from the user, stores it in the integer variable named value, and on the next slide you'll see the second half of this program that implements a while loop based upon value. So the Boolean condition evaluated by the while is value not equivalent to 0, and then within the body of the while loop we solicit another integer from the user to add to the sum. So the sum is an accumulator variable, and we're adding value to sum each time, and then the sentinel value in this case is 0. That will cause the while loop, the condition in the while loop, to be false, and the while loop will terminate. Here's some more review. The while loop can be used to validate input. So, for example, in this program snippet, we're evaluating whether or not the input, the value in input, is positive. If it's less than or equal to 0, we're going to tell the user to input a positive value, and we're going to scan another value into input. So this will continue to prompt the user, as long as they're entering negative values or 0, to enter a new value. Here's a simple Java program that implements a while loop to demonstrate input validation. It's soliciting an integer value from the user that represents a number of games, 1, and that value needs to be between 0 and num games, which is a constant specified at or set at 12 in this example. On the next slide, you'll see the actual while loop. So while the value 1 is less than 0 or greater than the number of games, which is 12, the user is prompted to please re-enter the value because it's invalid. You can't have a negative number of games won, and you can't win more games than the total number of games played, which was 12 in this case. And so it will continue to validate the input until invalidate the input until it gets an appropriate or acceptable value, and then it, prints looks like the percentage of games won. This should really be reviewed. If it's not, you should start to worry. The body of a loop must make the condition false eventually. If not, it will be an infinite loop. It will execute until the user interrupts the program. And this is a common logic error. So you have to have something within the body of the loop that will change the condition so that it will eventually become false, whether it's more input from the user, whether it's a counter that's incrementing or decrementing towards a boundary condition. But we discussed this ad nauseum in the prerequisite course. A classic example of an infinite loop. While count less than or equal 25, well, count starts at 1 and then decrements within the loop. So it will always be, it's moving in a negative direction. It will never approach 25, the boundary condition. Nested loops work the same as nested branches or nested if statements. That is, the body of a loop can contain another loop. Later in this course, you're going to see this implemented quite frequently. So for each iteration of the outer loop, the inner loop iterates completely. Coded example of a nested loop. Looks like the outer loop starts at 1 and gets incremented by 1. So it will start at 1, less than or equal to 10. So the outer loop will execute 10 times. But for each iteration of the outer loop, we'll drop into the inner loop, and it looks like that'll go 1 to 50 by 1. So 50 times, this will execute 500 times. Now we take a look at the palindrome tester program, which implements a nested while loop. What is a palindrome? A palindrome is a string of characters that is symmetrical around the center point. It needs to be an even number of characters. And so let's take a look at how this works, and you'll understand what a palindrome is. And if you don't, Google it. It's really straightforward. So in this example, our outer while loop mimics a do while. It really says while another equals ignore case. Another is a string initialized at a lowercase y. And equals ignore case is a method of the string class that determines if two strings are equal, irrelevant to the case. So it sets everything to the same case, if you will, or ignores the case. So it allows the user to enter a lowercase y or an uppercase y, and it ignores the case. So the user enters a potential palindrome that's stored in the string str. It sets left, which is an integer, at index 0, and right string.length, which will get the length of the string. That's the number of characters, but remember, if it's 10 characters, it's going to be index 0 through 9. So string length -1 will set right at the index value of the character, the last character in the string. Then it's simply while string.char left string.char 0 equals or is equivalent to string.char right, which is going to be the rightmost character in the string, and left is less than right, because remember, a palindrome has to be an even number of characters to compare the symmetrical left side to right side. And then, so if they're, while that's true, we move left 1 and right -1. So we'll simply compare the characters, and if left is less than right, it's not a palindrome, else the string is palindrome. So when this ends, right, when this ends, this should all be true. Let me give you a test run as an example, and we'll see what a palindrome looks like. So I could enter the palindrome ABC, CBA. That string is a palindrome. It is symmetrical around the center line, or the first half is then continued backwards last half. I'm probably not doing a good job of describing a palindrome technically speaking. So let's see, ABCD, BCA is not going to be a palindrome because it's not symmetrical. Okay. Hope this helps. I strongly urge you to download this code, run it in Java, if not just for practice to get started with running projects in Java. An iterator is an object that allows you to process a collection of items one at a time, steps through each item in turn and processes it as needed. An iterator object has a method named hasNext that returns true if there is at least one more item to process. The next method returns the next method, so you can use hasNext as the Boolean to continue to process the next method. I'm sorry, the next item. And we're going to cover iterators in more detail when we get to chapter 9. Some classes in the Java API are iterators. The scanner class is an iterator, which means it has, no pun intended, it has the hasNext method, and it returns true, and it has the next method, returns the next scan token as a string. The scanner class also has some variations of hasNext, such as hasNextInt. It will return true if the next token in the stream is an integer. And as you might have guessed, the fact that the scanner class is an iterator makes it extremely useful when we're reading input from a file. So suppose we want to read and process a list of URLs stored in a file. One scanner can be set up to read each line of the input till the end of the file is encountered, and another scanner can be set up for each URL to process each part of the path. Now we take a look at a program that demonstrates the use of a scanner to read input from a file into a string, and then we're going to use a secondary scanner along with delimiters to parse that string. So here we have our string URL, and we have a file here that we're connecting the scanner to, website.inp. I'll give that to you in the Canvas timeline. You just drag that and drop it into the root for the project. And I'll show you what that file looks like. Here it is, websites.inp has a series of websites. Some have the forward slash, some don't. Some have multiple forward slash. So we're going to parse these. We're going to read each line into a string using the file connected to a scanner. And then we're going to have a secondary scanner that's going to use the that particular string, and we're going to parse it into its pieces. You'll see what happens in a second. So file scan is a new scanner with the file connected, and while file scan.hasNext, right, it'll process each line of the file. We're going to take the next line and assign it to the string URL. And then we're going to print string literal URL and concatenate it with the URL string. Then we have a secondary scanner called URL scan, and its input source is going to be the URL, that particular string that we just scanned in. Scanner has a method named useDelimiter, which requires a specific string that will be used as a delimiter for hasNext. So now hasNext doesn't go to white space, it goes to the delimiter. So while URL scan.hasNext, while there's a new part to be parsed, system.out.println space plus URL scan.next, that next part up until the delimiter or the end of the line. So here's what the output looks like. I've already run this. The first URL, google.com, www.google.com. There is no parsed second section because that first website had no slash in it, so there's no delimiter. Second one has a slash, so we're going to see URL, the entire URL, and then the two components that's the first next and that's the second next because we set the delimiter as a slash, etc., etc. Hope this is useful. I'll put this in the Canvas timeline. I strongly urge you to download this because this is kind of new. This is not review. So take a look at it, run it, and obviously if you have any questions, ask me. This is 100% review. The do loop, also called the do while loop in C++, has the condition after the body of the do while. So the statement or statements in a body are executed a minimum of one time before the condition is evaluated. Here's a diagram of the do loop. As I mentioned, the true statements or statement are always executed at least one time because the condition is not evaluated until after it runs through the statement or body of statements in the true. More review, exact same syntax as in C++. Here we have a program that demonstrates the use of a do loop. Its setup is on this page and the actual do loop is on the next page. It will, the Boolean condition will be based on the value of number, which is an integer. Do loop will run the body of the loop at least once while number is greater than 0. 100% review, comparison of the while and the do while loop. The while loop has the potential to run the body 0 times or never. The do while loop does not have that potential. It will run the body regardless of whether or not the condition is evaluated as true the first time it is evaluated. Next up is the for loop, which is No surprise, exactly the same syntax as it was in C++. You've got the initialization, the condition, and the increment, and then the body, either a single statement or a body. Once again, more review. This is a diagram showing the flow of the for loop. The for loop is functionally equivalent to the following while loop structure. You've got an initialization, you've got an increment built in. So there's nothing the for loop can do that you can't do with a while loop. It just makes it a little bit more compact. Just as in C++, the initialization section can be used to set the value of an existing previously declared variable, or it can be used to declare and initialize a variable. And as in C++, the increment section can perform any calculation. For loop is best suited for executing statements a specific number of times that can be calculated or determined in advance. Next two slides show a simple Java program that implements a for loop. You'll see this page, we're soliciting input from the user to initialize an integer named value and an integer named limit to set up the boundary conditions for the for loop, which we'll look at next. And no surprises, here's the actual for loop. We set the variable mult to the initial value. That's the initialization. The Boolean condition is mult less than or equal to limit, and mult plus equals value. So value gets added to mult each time. And as with any other loop, we can have nested for loops. And this is a small program which shows a for loop within a for loop. I'm not going to go into great detail. This is all review. Obviously, you'll have access to these files if you want to run them on your own computer at home. You should know that each expression in the header of a for loop is optional, but strongly advised. If you leave out the initialization, there's no initialization performed. If the condition is left out, it's always considered to be true, and it'll be an infinite loop. And if the increment is left out, no increment operation is performed, then most likely that will yield some sort of some variation of an infinite loop. To end this lecture, we have a short topic to cover: iterators and for loops. So there's a variant of the for loop that simplifies the looping process for any object that implements the iterable interface. So the iterable interface provides an iterator, basically. So for example, if book list is an iterable object, and I know we're getting to classes and objects after this lecture, so just hang in there. If book list is an iterable object that manages book objects, the following loop or variation of the for loop will print each book. So for book, my book, colon, book list will simply print each book object. And as we get further into classes and objects in this class, no pun intended, this will become obvious. This version of the for loop is sometimes referred to as the for each loop. The style of this for loop can be described as for each book in book list. It eliminates the need to call the has next and next methods explicitly, and it'll be very helpful when we start a discussion on arrays in chapter 7. That's the end of this lecture. Thanks for watching. It was 98.3% review, I think I said at the beginning, but no, most of this is review. So a couple nuances or changes in syntax and application between Java and C++ in the conditionals and loops, but I think I've covered them here. Thanks for watching.